user research suggests that user attention actually starts to dwindle after they have to wait around 100 milliseconds. So if you're waiting 200 or 300 milliseconds or 500 milliseconds just to cold start before your application even starts running and then you're returning data to the user, you're playing at a supreme disadvantage. We really want to be able to say to people, hey, this will do better for you if you're writing your applications this way. It is legitimately faster than these systems that were built on a technology that's 10 or 15 years old.
Hey, this is Brian, and you're listening to Jamstack Radio, a bi-weekly series where we discuss modern web development with maintainers, founders, and developers. Jamstack Radio is brought to you by Heavybit, the leading investor and developer-first startups. For more information, visit heavybit.com. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us on Twitter at Jamstack Radio. Welcome to another installment of Jamstack Radio. On the line, we got Matt Butcher from Fermyon. Matt, how you doing?
Great, and thanks for having me. I'm really excited about this.
Yeah, pleasure. And I honestly, I saw you come through one of my feeds on another podcast, and I meant to listen to that before this podcast, and I never got to it. I've been very, very, very busy with the day job, and so podcasts have been on the wayside. No commute to listen to a podcast anymore.
Yeah, I'm way behind on podcasts now.
Excellent. We got to do some yard work. That's the one time I get when it's not raining down here. Because are you in Seattle?
No, I'm in Colorado.
Colorado, okay.
Yard work for me is shoveling snow.
Excellent. Yeah. Well,
Yeah.
That's podcast time.
Yep.
Why don't you introduce yourself? Because since we're so comfortable with each other, we're talking about a yard work.
Right.
Who's Matt and what's Fermyon?
So, and I think I could start with, Brian, where you and I met, because you and I met at Fermyon, the first Fermyon appearance ever at a conference. We were at Open Source Summit North America last summer. Yep. So before that, actually, we crossed like ships in the night, I think, again, because I came out of Microsoft. I had, was very early in the container ecosystem and was working at a company called Deis, and containers had just reached that point at which they were looking stable enough that you could build a real thing on top of them. And at Deis, we wanted to build a platform as a service. We wanted to build a competitor to Heroku. And so we just sort of dove into all of these sort of like rapidly emerging standards and rapidly emerging open source projects. So we were using, like early on, we were using the Fleet scheduler from CoreOS. Fleet kind of got EOL'd a little bit right after Kubernetes. CoreOS got acquired. Yeah. I was going to say Choreos is what we used to call it on the street. Yeah. They missed a major branding opportunity there to have a sandwich cookie for a logo.
Yep.
But yeah, we were really into the early kind of container ecosystem, and I'd worked at Google in the past. And so when Google dropped this open source project that none of us knew how to pronounce initially and said, this is how we're going to schedule containers, check this out. And we all started playing around with Kubernetes at Deis, and the experience was game changing. Right. We found this was when Kubernetes was actually a fairly simple and fairly straightforward technology to use. And we were like, oh, we've got to re-platform. We are going to re-platform this entire PaaS on top of Kubernetes and be the first PaaS offering on Kubernetes. And so we started going like all out on this. So, around the same time as we were making this big transition, Kubernetes started gaining some traction, and Microsoft pulled one of those moves where they're like, hey, Brendan Burns, guy who invented Kubernetes, how about if you leave Google and come over here and build the world's greatest Kubernetes team? And Brendan's like, yeah, why would I pass that up? So he left Google and went over to Microsoft. And a big part of his job was assembling a big team that could turn Kubernetes into sort of the next big Azure service. So he and a couple of other folks like John Gossman, they sort of orchestrated the acquisition of Deis, which was awfully flattering to know that somebody like Brendan was paying attention to our little Boulder startup. And we all joined Microsoft. And they divided us into two teams. And one team became the team that built AKS, the Azure Kubernetes Service, a really, really awesome team that just knew how to get stuff done. And they built this service in, I think, record time. And I know that it was the fastest growing Azure service in the history of Azure. They just knocked it out of the park. My team became the container open source development team. So we were kind of R&D, and we had kind of two things that were our mandate. On one hand, it was like, Brendan's like, look, just build open source tools that the developers love to use, and all in the container ecosystem and the Kubernetes ecosystem, to get folks under, trying new tools and going, oh, this Kubernetes thing is really powerful. I can use it to do this. I can use it to do ETL transforms and stuff like that. So it was a great job. And then the other half of that job was, really more from Satya. Satya had really kind of wanted to pivot Microsoft from being perceived as sort of hostile to all open source to being actually good, healthy, honest participants in open source ecosystems. So it wasn't like a marketing thing. It was like, no, you actually have to do the work. You have to be a reasonable human being who loves people and wants to contribute upstream. And so we were part of that kind of movement inside of Microsoft. And the combination of those two things made this what I really think was, one of the best jobs one can have inside of Microsoft. So we got to go to all the open source summits, all the KubeCons and things like that. And we got to talk to internal Microsoft teams, the rest of the core Azure teams, the .NET team, the HoloLens team, and just kind of learn what they were trying with cloud and what they were succeeding with and what was really hard. And then we'd go talk to customers and do kind of the same thing with them. And out of this, we would kind of fill our hopper with ideas of things that people were struggling with. And we kind of came into this with Helm. Helm was the package manager for Kubernetes, and that was one of our team's projects. One of the things we built at Deis that Microsoft acquired. But then we just started piling more and more open source projects on top of these. Draft was a tool for quickly building Kubernetes applications. Brigade was a tool for doing data pipelining. And it was like, by the time 2020 hit, I think we were at 8 or 9 open source projects that were all inside of CNCF. One of the things we discovered, though, was that there were problems that we couldn't solve terribly well. So the team got together and we said, got this bundle of problems that we cannot figure out how to do with containers, can't actually even figure out how to do them with virtual machines. And these are things like we wanted to be able to scale down to 0. So when no traffic is coming in, why do you need 3 copies of your server running? Can't you just scale it all down to 0? And then when traffic comes in, scale it up to 3 or 5 or tens of thousands or however many you need. And we tried to do this with containers. The startup time on containers was just too slow. We tried all kinds of hyper optimization techniques on virtual machines, still same story. And so we had, that and a couple other problems, cross-platform, cross-architecture problems and things like that were starting to pile up. And try as we might, we couldn't come up with a good solution. And we're sitting at dinner one night after we'd spent the whole day planning. The whole team was offsite doing this planning, and we were just in that decompression mode. And you know how sometimes you get into the decompression state, and rather than becoming exhausted, right, and just being like, you get into this kind of like creative mode where you're kind of like, wouldn't it be wild if? Or, how come we never thought about this? And we started talking about maybe there's a third kind of cloud computing that nobody has noticed. Maybe we've got virtual machines, containers, and an empty bucket where we could put a third kind of cloud computing. This kind of thing that should be able to scale up and down rapidly, that should have near instant start times, that where you build it once, you should be able to run it on any hardware in any operating system. Wouldn't that be cool? And, we brainstormed a little bit about that, and a couple of us got interested, and we really started running with it. That was, I think, late 2018. And so 2 or 3 of us played around with all kinds of different things and ended up looking at WebAssembly as a potential candidate for solving it. So it's probably a good time to pause and explain what WebAssembly is.
Yeah, I would. Yeah. I think a lot of people have heard the terms, and I think we've all seen like some conferences and maybe seen Mozilla employees talk about it.
Yeah.
But yeah, a refresher would be great because I know it's been around for quite a few years.
Yeah. So WebAssembly was originally, okay. So you can take like a really positive, awesome vibe kind of, here's what WebAssembly is, or you can take the kind of realist vibe. I'm going to go for the realist one here just to throw it in for a change.
Okay.
It will not solve all the problems in the world. I'll just get that out there. Realistically, the browser has had kind of a checkered history with language support. right? So, the first real language that was supported in browsers, at least in Netscape, was Java, right? And they needed a language to kind of tie Java together with the rest of the platform. And, Brendan Eich famously spiked out in like a week or two this thing that he originally called LiveScript that they renamed to JavaScript because Java had so much marketing momentum, right? And so you had Java and JavaScript in the browser. JavaScript, I'm old enough that I wrote JavaScript when it was still called LiveScript, and you couldn't really you could pop up alert dialogues, you could, put things in the status bar, which I don't think you can do anymore. It was a toy language, right? Applets were Java applets were supposed to be the way that we wrote really rich in-browser code. As we all know, I don't even think applets are supported in any major browser anymore, right? That it was just a technology that kind of came and went.
Yeah.
And then there were a whole bunch of others, right? There was ActiveX, there was Silverlight, there was Flash, and all of these things really kind of at the core were attempts to take the browser and treat it as a runtime for another language or embed a runtime for another language inside of the web browser. So meanwhile, all of these projects are coming and going and sort of languishing, and then ultimately kind of support just fizzles out and they drop out of the browser. Well, JavaScript is like totally kicking butt and taking names, right? It goes from this toy language that you can't do anything with to this language where you can start writing rich in-browser UIs. And then you get to the point where a couple of people start going, well, wait, we can take the JavaScript engine out of the browser and build, Node.js. And then Deno Ryan just keeps building cool stuff, right? Node.js and then Deno. And then we start to see, Vertex, which I think also kind of came and went. All these technologies are pulling JavaScript engines out and starting to do sort of server-side JavaScript and cloud-side JavaScript. Meanwhile, the browser is kind of stuck in this JavaScript-only mode. So that's kind of the stage set for where WebAssembly came from. So Luke Wagner and a couple of other people working at Mozilla were kind of looking at this problem and going, well, maybe it's just that up to this point, a lot of technologies have been dropped in the browser as sort of like extension third-party things that were really designed to help Microsoft or Adobe or Sun, right? So, or now Oracle, right? What if we wrote a generic runtime, a specification that would run, that ideally any language could compile to, and then we could run that binary format inside of the browser. So we should be able to start with C, compile C to this web-like assembly language, and then be able to execute it in the browser and tie together the JavaScript and the C code or the compiled C code and get some higher degrees of interactivity. And that was really kind of the origin story with a bunch of details omitted. That's kind of the origin story of where WebAssembly came from. So, kind of early on, the goal was to support languages like C. And then because it came out of Mozilla and Rust came out of Mozilla, Rust became a very early language. And then you started to see a trickle of other programming languages originally kind of support this in-browser model. The browser version didn't quite take off to the extent that I think we had all kind of expected it to. Maybe it's because the core thesis there wasn't right, that it's not the case that what we really wanted was a generic one, or maybe it's just because JavaScript at this point has gotten so powerful and so prolific that maybe the use cases were much narrower than what people originally thought. But the engine itself was really awesome, right? Figma, I think, is probably my favorite example of people who did cool stuff in the browser with WebAssembly. They took a C++ code base, compiled it to WebAssembly, exposed it to their JavaScript, and Figma is one of my favorite tools, period. So I'm totally happy with the way that worked out for them.
Yeah, powerful product too as well. Like Figma, they kind of unearthed everyone tries to do multiplayer in their applications. Mm-hmm. And I think Figma successfully made that work. And now I'm seeing a lot of other cool tools, which Sunil Pai actually has a tool that he's working on. I don't think he's announced it publicly yet, but it's not in stealth mode, that does really cool things.
So you heard it here first.
Yeah. But yeah, please go on too as well. So like we've got Figma, popular C++ in the browser using WebAssembly.
Yeah.
So I want to get to Fermyon too as well. So we all understand WebAssembly exists. I definitely have seen all the talks every year from Mozilla employees to talking about like this being the future.
Yeah.
But also I do write a ton of JavaScript, and I probably won't be like it's good enough. Like we were talking before we hit record. It's like I have enough gray hairs that like I don't think I'm going to learn new languages like every weekend. I know the ones I can write code with and ship a product with. So that's me. But like, where are we today with WebAssembly?
Yeah, and I think I can kind of pull the two stories I was just telling together, tell where Fermyon came from, and answer your question sort of in the process there. So on one hand, right, we started with the story of a frustrated team at Microsoft that was really trying to push the limits and find a new kind of cloud compute. Then on the other hand, we're telling the story about a really awesome technology in the browser that just for whatever reason didn't take off, you know, in the way that maybe we had all looked at it and expected it to. So here we are looking for a really cool candidate to be a third kind of cloud computing, and our set of criteria are fairly well fleshed out. But one of them was, you know, it needed to run in a very secure sandbox. And that was the one that got us looking at WebAssembly, because we're looking going, okay, where do people build highly sandboxed runtime environments? Well, the cloud. Okay, well, we've already exhausted that one. We can't find anything new there that's going to cut the mustard, you know, past the checklist. But the browser is another one, right? And when you think about it, the browser is one of the most interesting, highly trusted platforms we run. We load random web pages that we have no idea who authored these things. And they're loaded with JavaScript, and we don't give a second thought about the fact that it's executing an entire application because we trust the security sandbox. WebAssembly had to have an even tighter security sandbox than JavaScript did, right? Really, it was a capabilities-based model where by default, the code executing in the WebAssembly runtime isn't allowed to access anything, right? You have to tell it, okay, you know, you can call these functions. Okay, you can do this. The JavaScript outside can call into it. And that was really kind of the security model that is necessary for the browser. That's the security model we wanted for the cloud, because what we wanted is to be able to run untrusted customer workloads, right? And say, yeah, whatever, you know, we're not going to need to scan your software before you can execute it in the cloud, right? We don't do it with containers, don't do it with virtual machines. We certainly didn't want to do it in whatever our third cloud runtime was. So that got us looking at WebAssembly. We ended up starting Fermyon, the company, with the idea of saying, okay, based on kind of what we have learned, if we were to start over and write this kind of third kind of cloud computing thing, what would it look like? Let's go build it. And so that kind of brings us up to about where you and I met, Brian. You know, Open Source Summit North America last year was kind of our first real sort of public demonstration of what we had built, which was a Spin, an open source developer tool that's designed to build applications, really focusing very much on the kind of serverless mode of writing applications, serverless functions. And I can come back and talk about that in a minute, but that's really been our focal story. So we've got a developer tool, Spin, that can do that, and then a cloud platform, Fermyon Cloud, where you can execute these things. So you deploy your application up to Fermyon Cloud. If you want to run it kind of on your own devices, on your own cluster, on your own bare metal, you can use Fermyon Platform and install this kind of platform on DigitalOcean or Equinix or whatever. And that kind of brings us to your question, right? Yeah. So we kind of tie the two together and then go, okay, so what is WebAssembly now, and what's it doing, and how are people using it? So we were not the only people to look at WebAssembly and say, "Oh, this is a really promising technology." In fact, as you've noticed, Brian, in all these conferences and podcasts and articles, people are finding a bunch of really novel applications for this technology. Again, because kind of the same virtues that attracted us are attracting people in other places. I tend to think there are kind of four big places where WebAssembly seems to have gained serious traction, right? The first one is the browser, right? We talked about that, places like Figma and Adobe. But IoT is another surprising one. I worked in that field for a long time, and the challenge is you're to some extent, you're stuck writing a lot of low-level code like C, right? Whether you're doing industrial IoT or whether you're doing consumer IoT, you've got this low-level C code base. And then you've got to somehow build the application on top of those low-level drivers for sensors and processors and things like that give the user a good experience. So WebAssembly turns out to be, because it's so easily embeddable, and again, because of that great security model, turns out to be a really good fit for the IoT model, where you can write the low-level C code, add on a WebAssembly runtime, build all of your application in a higher-level language of your choice, compile it down to WebAssembly, and execute it. So BBC, Amazon Prime, Disney Plus, they're all big users of WebAssembly for their streaming players, because they can, write some low-level shim code for every TV and set-top box and Roku and Apple TV that you have out there. But then the application code that runs on top of it can use common libraries and be, you've got a lot of code reuse that can happen at the higher levels. Gives you a good over-the-wire update kind of story. It's kind of a cool technology. So that's number 2, right? Number 1, browser. Number 2, IoT. Number 3, I think, is more on the plugin side, where your typical when a plugin or an extension, right? You start introducing these to your tool when you want to make it possible for other developers to bring value to your tool, right? Browser is a big example of this. Even web platforms like Shopify. Shopify uses WebAssembly so you can write custom extensions and deploy them into your Shopify environment. There are all these cases where really the use case is, I have a platform. I want to expose to you, the developer, a way to extend that platform to get more of your stuff done so that A, I don't have to do all of the work, and B, you can get stuff done the way you really prefer to get stuff done. And I think one of the most novel ways I've seen this kind of plugin-y architecture used is from Single Store. And now I think other database companies are kind of following along. But Single Store went, nobody likes writing stored procedures in SQL. What if we just made it possible to write stored procedures in Python, compile it to WebAssembly, and push it into your database? So instead of having to suck data out of the database, transform it, and then put it back in the database, you can transform it inside of the source that already has all the data. And I think that's just a really, bring the code to the data is a really nice way of applying that kind of plugin model. So I'm a fan of that kind of thing. Then the 4th one's the one I love, right? And that's the cloud environment, where I just feel like WebAssembly is a great cloud runtime that has some very specific applications. And consequently, Fermyon has built our platform on that.
Yeah, so to be clear, like Fermyon, am I writing the code I want and then using Fermyon to deploy that and have fast compute without the sort of like, the complaint is like, it's not fast enough. So like you got to do Rust or you got to do Zig or whatever the new hotness is. So like, what am I actually deploying to Fermyon? Because you mentioned like serverless functions in compute. So Am I writing my code and deploying that directly to your cloud offering?
So the problem that we identified to solve was that what we were hearing, and this even back in when we were at Microsoft, was that developers really liked serverless functions, right, as a development model.
Yeah,
because you dive right into the code you care about.
I'm a fan.
Right? Yeah.
Yep.
You don't have to stand up an HTTP server. You don't have to spend half an afternoon configuring TLS. You don't have to do any of the process management. You just write a request and response handler, right? But the problem was that most of the architectures built on that are built on fairly aged technologies. Lambda, every function is executing on a virtual machine. So that's, virtual machines like a very heavyweight object, right? And they're not fast to start up. And consequently, to be able to execute Azure functions, Lambda functions, Google functions, those kinds of things, essentially they have to keep around a pre-warmed instance of a VM that they can drop the code on in the last mile and try and execute it. And even so, they're talking about 200 milliseconds to 500 milliseconds to cold start your application, even though your application is just a function, right? So we looked at that and went, that's an architectural thing. The problem is it's the wrong cloud runtime. Now, there's another aspect to the same problem, which is that developers complain to us quite a bit that writing serverless functions is great when you're in your IDE, and then you spend 45 minutes configuring an environment to run this thing. And I actually timed it. I did a straight Lambda function, start to finish, from an existing account, to like, okay, what does it take me to get there? And I was in at about 47 minutes from that to having Hello World deployed. And I'm like, okay, I understand why people are complaining, right? This is just a long time. So we looked at this and said, all right, developers have told us about something they love, serverless functions. They've told us about a couple of things they really don't like, really long cold starts, really clunky developer experience. So we really wanted to solve those two problems. So we built Spin, an open source tool, to make it super easy to write these kinds of applications. And then Fermyon Cloud is one way to deploy these applications into the cloud to be able to run them at. So 200 milliseconds for a Lambda function, we cold start in a millisecond. Okay. So a couple orders of magnitude faster. And the reason why is because that's just, WebAssembly is just that fast. And when you can optimize your binaries and upload, you can make it even faster. And 1 millisecond is a good solid starting point.
Yeah, I don't mind that one. Yeah.
Yeah, not at all, right?
Yeah.
Yeah.
Now that I have a better understanding of the platform, like it sounds like we at Open Source, like my day job, we have things that run in cloud. And like the questions that we have now is like, we are choosing to use Jamstack projects to host our serverless functions, like netlify functions. It's like, don't build a whole like a Lambda and then maintain that and upload it with a zip folder or anything like that. Like, it's nice to have the functions to compute, but it's the same, cold start. It's the same, like we're not owning that infrastructure.
Yeah.
So like our enterprise product that we have not started working on as of yet, but anybody who's a VC, it's going to be done soon.
Same for us, by the way. Yeah.
Yeah. But what we need is we need to be able to host the stuff in the cloud that people could run or host on their machine and their compute. But we also have the slowness of it's going to take so for example, the Linux Foundation Insights is a sort of a competitive product to what we're building. It's just only for Linux Foundation companies. Their data takes at least 24 hours or even a couple days to sort of update. And the reason for that is it's got to go through all these Git commits and turn that into insights. And what we're trying to do is build something that's much faster that we can do on demand and folks can use on their local infrastructure or host in the cloud. But it sounds like if we just wrote some JavaScript and put it up on Fermyon and leverage the power of 1 millisecond WebAssembly, we could be extremely competitive.
Yeah, I mean, and I think any of these kinds of cases where you're looking at a FAS kind of system like Lambda and going, okay, well, we could write pipelines to do it this way. Yeah, that's the kind of workload that we love to do that. And, web application backends and things. Another nice thing about this kind of technology is, we know user research suggests that user attention actually starts to dwindle after they have to wait around 100 milliseconds. So before you're even aware of the fact that your attention is starting to wane. So if you're waiting 200 or 300 milliseconds or 500 milliseconds just to cold start before your application even starts running and then you're returning data to the user, you're playing at a supreme disadvantage. So we were serverless functions should be the kind of thing where we can write them and there's no cold starting there. You can deliver things nearly instantly. Fermyon.com actually runs on our own platform. And a big part of the goal was, okay, the Google page speed test, we need to score in the high 90s. We got all the way up to 100 at one point, and then I think we're back in the 99, 98. But part of that was because we know, okay, we really want to be able to say to people with a straight face and in all honesty, hey, this will do better for you if you're writing your applications this way. It is legitimately faster than these systems that were built on a technology that's 10 or 15 years old.
Yeah. I'm excited to try this out. As I mentioned before we hit record, I'm no longer doing full-time engineering, but I'm happy to do a weekend project. And this sounds like perfect weekend project stuff.
There you go. That's what I want everybody to say. Yeah, I'll try it over the weekend. And then on Monday, I'm just going to spend a little more time working on it. And then Tuesday, I'm going to start a new project.
Yes, exactly.
I love that.
It becomes a huge spike. And then now little do you know, it's now embedded in the entire infrastructure.
Right. Yep. That's right. Yeah.
Perfect. Like I said, I'm excited. I hope the listeners are excited to try this out. I did want to actually ask the question of the name. What's the history behind the name?
Oh, and I'm the worst person to ask because I'm my actual educational background. I have a PhD in philosophy. Okay. So I have basically nothing in the realm of the hard sciences. Everybody else at Fermyon is more interested in physics and stuff like that. And Fermyon is a term in physics. There are fermions and there are bosons, and nobody wants to have a company named Boson.
Okay.
I don't know why. So fermions are small particles of which everything else is composed. So we like that idea of the function as a service is this little particulate piece that the bigger applications are composed of. And fermions tend to have a couple of characteristics, one of which is spin. So spin is actually a pun on fermion. And if you ever got really bored and perused our code base, you would find all kinds of very nerdy physics references that I actually don't understand. So
that's amazing. Yeah. So next time I see y'all at an open source summit or KubeCon, I will corner the team and ask them more questions about these physics terms. But very clever. Cool. Anything else you mentioned? We're actually sort of winding down the conversation before we hit picks. But anything else in the Fermyon world that you want to share?
Yeah, I mean, I guess we didn't really talk about languages much. Another big deal to us was to be able to support a broad swath of different languages. And we started with kind of the core compiled languages, Rust, Go, and we've kind of worked our way into scripting languages. Most recently, we added Python support and then we added JavaScript support. But that's a big deal. And one of the ways we think is a key interesting differentiation point is that if you can compile it into WebAssembly with the system interface extensions, you can run it on Fermyon. And I think that's a really good thing. Oftentimes, these kind of serverless platforms have to zero in on either one language or a small set of languages. And we've been trying to make it possible for to add, a plethora of different languages.
Excellent. Yeah. Well, looking forward to seeing more language support. It seems like there's a few new languages that are coming out. I mentioned Zig in passing, but yeah, Zig is something I've been looking at as well. It seems like people are getting a lot of success from that, or at least a handful of companies are.
Yeah.
And maybe you'll have Zig support pretty soon as well.
You actually can write Zig apps today if you want.
Okay, excellent.
Usually not the most catchy one to lead with. WoW's all of like 9 people, but Zig is an awesome programming language. I really do like it. It's actually easier to compile C with the Zig toolchain, C to WebAssembly, than it is to use the C toolchain to compile C to WebAssembly. It's a great tool and is supremely architected. I'm a big fan of the Zig team and the work they do.
Cool. Yeah. I've got to reach out to the foundation, and looking forward to connecting with them and learning more.
Yeah.
But with that, I do want to transition us to picks. So folks, definitely try out Fermyon and Fermyon.com too as well. And it actually it's how it's said is how it's spelled. So if you're not a physics major, you'll find it also in the show notes. But Matt, we got jam picks. These are things that we're jamming on. It could be music, food, technology related, all of the above. Everything's on the table. And if you don't mind, I'll go first. I've got 2 picks. One pick is I've been using lots of looms recently.
Oh, yeah.
I've been doing this thing because our team's all remote distributed. Actually, is Fermyon also distributed, or do you guys have a...
Yeah.
Okay.
Yeah, very similar to you.
Yeah. So I've been doing these Monday morning, here are our metrics, how many user signups, how many people have done this interaction on the page. And I try to accompany that with a video. Mm-hmm. So I've been doing, what I've been doing with those is Slack videos, which is very much like a loom, 5-minute limit. Quick, hey, here are the numbers. Here's a quick demo. Here are some things that are high priority fixes. Here are conversations that I had last week, and sort of summarize the day. I find it's better than even having all hands, a whole hour long conversation. Yep. It's a quick 5-minute, hey, State of the Union. This is where we want to start the week at. And then we have a normal meetings and stuff like that. But I've been doing Loom videos and quick, hey, I just talked to a potential customer. Let me just do a quick video, walk through that demo, send it over to the designer, and get that feedback loop going. And it's so much better than jumping on an hour-long call, because these meetings tend to be an hour. I don't know why they're always an hour long, but it's hey, can we just chat? And then it ends up being oh, let's talk about our weekend. Let's do so. This hey, we can have those calls, but let's do a Loom video, summarize whatever we're trying to get out, and then we could be better prepped to have when we do need to get on a Zoom or a Slack call or something like that.
I'm so glad to hear you say this, because we've been trying the same thing with Slack videos and Loom, particularly for internal messaging. And it's so great to be able to I'll record a 2-minute announcement video in the morning. We've got about 30 some people at Fermyon. 2-minute announcement video. And it takes 2 minutes of my time, and everybody feels a little more connected, and it's a meeting nobody has to go to. So I'm a big fan of Loom and the Slack videos. Yeah.
And that's Loom's the whole, what their tagline is it's always about how many meetings you were able to eliminate from the week. Uh-huh. And I started doing this thing with, maybe this is another pick, but Calendly. I've got a Calendly, but I can only book meetings out 2 weeks out. And the reason for that is because I was getting to the point where my entire month would be booked up. And it would just be impossible to find time to even have some deep work, because folks would just jump on the calendar whenever they could because they had the link. Yep. So I started turning off different Calendly. It's a season. Every 3 months, I'll turn off the one, and then the next quarter starts and I'll turn on the other one. But then you could only book a 2 week out, which basically helps me control the amount of meetings I have, because we're at this point 6 people, and we don't need that many meetings to get the job done.
No, that calendar, that's a great tip. I'm going to do that too now.
Yeah. And I had one more pick as well, which was my GitHub notifications, my management. Working at GitHub as a full-time employee, doing notifications is almost near impossible, because if you have any subscription to any big GitHub repos, like GitHub,
yep,
it's just impossible to get any sort of work done when you have the mono repo turned on. Mm-hmm. But it was not even just that. Every team has their own repo at GitHub. So when I left GitHub, it was a breath of fresh air to actually use notifications properly. And so my whole thing is if you need me to look at something, mention me, and it will show up in my feed. and I only look at mentions. And I'll just go down like either the morning or evening, just like email. I'll just go down the mentions and respond to stuff. And then that way I can keep up to date on what I need to review as far as code goes, or answer questions and random issues, or provide a quick little video or whatever it is. But my pitch to everyone on the team, @mention me. I'll get to it pretty quickly. If you don't want me to get to it quickly, just don't @mention me, and I'll find it in the next 30 days.
So is there an GitHub notification equivalent of inbox 0 then? You're at @mention 0 at the end of every day?
I've given up on inbox 0 and notification 0. Like if something's really important, people will bump it. Yeah. And I think that's just like, as engineers, we just know.
Yeah.
A quick little bump and a little ping just to get it back on top of the inbox, I think it's good standard. Every now and then people will abuse that and be like, hey, I opened this up 2 hours ago. Bump. And they're like, that doesn't work that way.
Aren't you back from lunch yet?
Exactly. Yeah. Yeah. I definitely had to like cut, because a lot of my team's Europe. So I had to cut myself off on how early I show up at the laptop, because I can get sucked in pretty quickly. And next thing I know, it's like 12 p.m. And I'm like, I have no idea what happened in the morning, but I got so much work done.
Yep. All right. Well, I've got two. And of course, I smuggled a WebAssembly one in here, a project from Bytecode Alliance called Wiser. And Wiser is basically a way to sort of pre-initialize. So WebAssembly, you can execute it, freeze it, and then store the frozen version and then start execution from there. Now, that's a generally dangerous thing to do. Wow. But Wiser is a tool that kind of makes use of that to say, okay, you can kind of pre-initialize your code, the early part of a startup, and then freeze it. And then you can cut that much time off your startup time in actuality. This has really awesome implications if you're doing scripting languages. So our JavaScript and our Python implementations, for example, the first step is you initialize the interpreter, then you start loading scripts in, and then you start executing. So what if you could start up the interpreter, load in all the scripts, and then freeze out the binary image there? And that's what we do with Wiser. It's a really awesome way of doing some performance optimization for scripting languages in particular. I think we also use it for .NET to start up the .NET runtime. So that's my WebAssembly one. And then this week, Apple released an app that I really do love that I use on my phone. I like to, whenever I'm coding, or even more so when I'm answering email and I need that kind of soothing vibe going on behind, I'm a big fan of a variety of classical music, especially like minimalism and stuff like that. Apple released a kind of version, I guess, of Apple Music that's called Apple Classical. That's just oriented more toward classical music. And I was skeptical when I first got it and thought this is going to be Apple Music with a bunch of different stuff in it. But actually, it really seems to kind of be tuned into what somebody who's looking for classical music is, where you're looking for a specific genre, maybe from a particular time period with a particular composer or particular music groups or forms of music performances groups, that kind of thing. It's clever. I like it. And I'm a big fan and have probably used it for about 15 hours so far this week.
Oh, so cool. I mean, today I learned. I feel like I've been like under a rock all week, real focused on a day job. But yeah, I'll definitely check out that app is for sure. And Wiser, like when you said it was dangerous, but like when you said you could freeze compute, I was like, wow, that's amazing. Like to be able to say like, okay, this process can start on Monday as opposed to work through the weekend. I'm trying to think of use cases I would use that, but if it's not recommended, maybe I'll give that thought process a break.
Oh, I mean, yeah, I didn't want to give the impression that I didn't recommend going and trying random things with this, because it's always fun. Just lower your expectations about your success of. But we tried to do this with containers many, many years ago and see if we could figure out a way to freeze a container and then move it somewhere and then reconstitute it. And it was fraught with peril. Yeah. WebAssembly is maybe a little closer to the kind of format you need for that. And you still would have to figure out how to do things like handles to files or handles to network sockets outside of the runtime. Yeah. But if you don't need to worry about those things, there's a lot more that you can sort of snapshot safely. So
yeah, that's so cool. Well, I mean, I feel like this is an awesome conversation. I feel like I'm significantly caught up to speed on like what's happening in the WebAssembly world, and super excited about the sort of success of Fermyon and what you guys are going to be doing in the future. So looking forward to rubbing shoulders again at a future conference and seeing the more ships and releases for sure. Now it's on my radar.
Thanks. Yeah, this is so much fun. Thanks for having me.
Yeah, my pleasure. And folks, keep spreading the jam. That's all we have time for today. If you're interested in being a guest on the show, or if you'd like to suggest a topic, find us on Twitter at Jamstack Radio. This show is brought to you by Heavybit, the leading investor in developer-first startups. To learn more about Heavybit, visit heavybit.com.